Okay, right, this video is going to be on types of ionising radiation. So, we've got the types of ionising radiation. So there are three types of ionising radiation we need to know about: alpha, beta, gamma. So, we'll start with alpha, and there's three things we need to know about each of them. So, alpha, which has the symbol alpha, so from the Greek alphabet. Now, alpha particle, this is the biggest particle. So, well, yeah, so it's in terms of the nuclear radiation, it's the biggest one. So it has the symbol quite often when you see it written in the nuclear equation, so I'll link to those, of 4 and a 2, or sometimes you can see it written like this. Now it's written with He for helium because it is exactly the same as the nucleus of a helium atom. So it's 2 protons and 2 neutrons. So this is a big particle. I've seen exam questions in the past where they've asked you the difference between a helium atom and an alpha particle. The difference between a helium atom and an alpha particle is a helium atom has electrons orbiting it in electron shells or energy levels around it. So that's the difference. This is just like the nucleus of a helium atom gets spat out. So nuclear radiation is when, and radioactivity is when atoms are unstable. So you think about a boat. If you keep piling things onto a boat, eventually as the cargo gets higher and higher, it becomes unstable and the boat's going to rock and things are going to fall off. This is what happens with atoms. Some atoms, the nuclei, has got too many particles in it, and it becomes unstable and it breaks down. It's radioactive. And when it breaks down, it emits these particles. Now, 3 of these particles are ionising, which we're going to learn about today. Another particle that can be emitted is a neutron, which is not ionising. It's not ionising radiation, but you still need to know that radioactive materials can emit from their nucleus alpha, beta and gamma, and neutrons. So, alpha is what we're going to concentrate on at the moment. So, it's the biggest one. And we want to draw it, what it looks like. Well, it doesn't really look like this, but for all intents and purposes for us at the moment, it's 2 protons and 2 neutrons. So, because it's made up of 2 protons and 2 neutrons, a proton has a mass of 1. And a neutron has a mass of 1, because we learned that before. So it has a mass of 4, because you've got 2 protons and 2 neutrons. This is a big particle. It has a charge of, well, neutrons are neutral, so they've got 0 charge, but it has 2 protons. So it's a charge of +2. So its charge is +2, and its mass is 4. Now, this is the most ionising type of radiation. So just talk about what ionising is. You know from your chemistry, you know things that, atoms have the nuclei in the centre, what we learned in the other lesson, and they've got electrons orbiting in these shells, or energy levels. Yeah, so we know that electrons are most likely to be existing within these shells or energy levels. Now, when an alpha particle hits into a material, what it can do, and what all these types of ionising radiation can do, is they can smash, if you like, one electron. So an electron can get smashed from there to there. If that negative charge, that electron, is knocked off this atom and knocked onto this atom is going to become positive. And this one is going to be, that's going to be a positive ion, that's going to become a negative ion. So it's ionisation. It can ionise materials by knocking electrons off one atom onto another. That, if it happens to DNA, and this is the key thing you need to be writing in exam, all these these three ideas. If that happens to DNA, it can damage the DNA, kill cells, increase the risk of cancer. So in an exam, if they ask you, what the dangers of ionising radiation, they can kill or damage cells by damaging DNA, and they can increase the risk of cancer by damaging DNA. So those ideas. Now, because alpha's the biggest particle, when it slams into things, it's more likely to cause this to happen. So it is the most ionising. So we only need to know now three properties of these, of alpha, beta and gamma. The properties are ionisation. So for alpha, it's the most ionising. The other thing we need to know is the range. How far these particles, when they're emitted, how far they can travel. Now, this is where you've got to sort of start applying your knowledge in an exam question, because alpha is the most ionising, which makes it the most dangerous, but only if it's inside your body, because actually the range of alpha is only 1 to 2 centimetres. Yep, so that could be radioactive material emitting alpha particles, and it's not dangerous because it's more than 2 centimetres away from me. However, if I was to eat that and it was inside my body, then it would be very dangerous. So it's the most ionising, but its range is only 1 to 2 centimetres. And then there's another thing about alpha, it's penetration. So in terms of penetration, that means what it's stopped by. And alpha can be just stopped by paper. So, if this is an alpha piece, if that was a radioactive source emitting alpha particles, I put a piece of paper in front of it, I've blocked it. It's not dangerous. And in fact, your body's covered in a layer of dead skin cells. Alpha can't penetrate enough into your body to actually cause any damage. So outside your body, alpha is not very dangerous. Unfortunately, if you ingest it, it's inside your body, it becomes very dangerous. And if you look up on the internet, quite interesting, Litvinenko, Russian man, I've said his name completely wrong probably, but a few years ago, probably about 10 years ago now actually, he was murdered by the KGB or the FSB, whatever they're called now in Russia. They came over, he was a old Russian oligarch, and they invited him out for a business lunch to a hotel in London, and they put polonium, which is a source of, which is a radioactive element, into his drink. He drank it, and then he became very, very ill a day later and died after about a week in hospital because he'd ingested the source of the alpha particles. So, key things. Ionising, alpha is the most ionising. Its range, 1 to 2 centimetres in air. Its penetration is stopped by paper. So, key ideas about that. Now, the next one we need to know about is beta. So, beta particles. That has the Greek symbol for beta. And you might see, when you see this one written in nuclear equations, it can be written like this, or you might actually see it written like that. Either way, you see that. If you look on the internet and things, you'll see it that way. This is the way it tends to be done in our syllabus, but they could do it that way. So, a beta particle. Now, it's important, because I'm going to spend a lesson talking to you, I'll do a little clip about the nuclear equations, but it's quite important for us to understand how a beta particle forms. And what happens is a neutron breaks down into a proton and an electron. And that electron is emitted, and that's why it has the symbol E in the nuclear equation sometimes, because it is an electron. So if you think you've got a neutron which has got a neutral charge, that breaks down and an electron is emitted, that leaves the atom, and that leaves behind a proton. because the neutron's lost a bit of negative charge, so it then becomes positive. It's the proton. And that's why, if you remember the 0 minus 1, the mass stays the same. So the atomic mass of the element stays the same because a neutron has just turned into a proton. So because of that, the overall number of protons and neutrons, protons plus neutrons, stays the same. You've got one more proton, one less neutron. So the mass stays the same. However, the atomic number goes up by 1 because the atomic number is the number of protons. A neutron's turned into a proton, so the atomic number goes up by 1 and you get a new element formed. Well, a different element formed in that sense. So, beta. Now, what do we need to know about beta in terms of its properties? So, we need to know its ionisation. Now, you'll see it referred to as weakly ionising. Beta's your average, is the average Joe of the particles. It fits in the middle. So, it's not the most ionising, but it's not the least. It's not got the most range, it's not got the least, it's not got the most penetration, it's not got the least. It's the one in the middle. So, its ionisation, it's weakly ionising. So, it's a lot less ionising than an alpha particle. Yes, an alpha particle is a great big particle. It's like being hit by a bowling ball. This is like being flicked by a pea. Yeah, it's a lot less ionising. However, it is, in terms of range, it has a much larger range, 1 to 2 metres. So where alpha can only travel 1 to 2 centimetres in air, this can travel 1 to 2 metres, which makes it more dangerous than alpha if you're further than 2 centimetres away from the source. So this comes into exam questions quite a bit. They talk about, which is the most dangerous, or how does the danger of the 3 types of ionising radiation change as you move further away from a sample. Actually, so if you go further than 2 centimetres, although it's less ionising, beta would be more dangerous than the alpha because the alpha's not going to reach you. And the same thing about penetration. It is only stopped by aluminium. So it can get through paper, but it's stopped by aluminium, about 25 millimetres of aluminium. So it's put a piece of aluminium in front of this and it's going to stop it. So lead definitely stops it. However, it's not stopped by paper, it's not stopped by your skin. So again, alpha, if you ingest it, you eat it and it goes inside your body, it's going to do you a lot of damage, ionising tissues as it goes around your body. But outside it doesn't, because it can't get into your body, it can't penetrate into your body. Whereas beta can. So outside your body, beta will pass into your body and it will cause ionisation and therefore could kill cells, damage DNA, increase the risk of cancer. So, it's the middle of the road one. We'll rub this out then. Right, the last one you need to know about is gamma. So, gamma radiation. Yeah, gamma rays referred to quite often. So, gamma radiation, gamma rays, it's what supposedly turned Mr. Banner into the Incredible Hulk in the Avengers or whatever you're watching. So, gamma rays. So, this has the symbol. I often think of it as a dead fish. It looks more like that, but you'll get away with drawing a dead fish upside down like that in the exam. So, gamma. Now, it doesn't have a nuclear equation because it's not actually a particle. When gamma is emitted, it doesn't change the atom. Yeah, so when this happens, the nucleus of the atom doesn't change. It is energy being emitted. It's an electromagnetic wave. So it's an electromagnetic wave, just like light is, just like radio is, just like microwaves are. Yeah, they're all electromagnetic waves. We'll learn about the electromagnetic spectrum, and it starts off with radio waves at this end, which are pretty harmless, going through microwaves, visible light, and then we get to UV light, which is ionising. It's not a type of nuclear radiation, but it is ionising. can cause skin cancer because it can ionise damaged skin cells, etc. Then you have X-rays, and you know you're only allowed so many X-rays every year. And then you have gamma rays, very high energy. They're more dangerous than X-rays and UV light, and they are a type of nuclear ionising radiation. So it's type of electromagnetic wave, electromagnetic radiation, and its energy that's emitted. Now, it is the least ionising. So out of all of them, it is the least ionising. However, its range is infinite. It doesn't stop. Yeah, so if it's emitted, it just keeps going. So it's got an infinite range in air, so you can't stand, there's nowhere you can stand, distance-wise, that's going to make you safe when it comes to gamma radiation being emitted. And also, penetration. It's only halved by sort of 25 millimeters of lead. Yeah, you can never fully absorb it all. It's reduced by lead. That's the best way of saying it in the exam. It's reduced by lead. So this can penetrate through lead, but it is stopped if you have enough lead. As we said, it's halved by 25 millimeters of lead. They do, if you look in some textbooks, it does say it's never truly completely absorbed, but you can reduce it with lead. But it's not, it's going to go through aluminium, which stops the beta, and it's definitely going to go through paper that stops the alpha. And therefore, outside your body, it will be dangerous because it's got an infinite range and it can penetrate your body and ionise tissues, increase your risk of cancer by damaging DNA, cells, etc. So, alpha, beta and gamma has no mass. Yep, so this one has no, gamma rays have got no mass and no charge. I didn't say about the mass of the beta, so sorry about that, I just realised I missed that idea off. Going back to beta, beta's mass is 1/2000th of the mass of a neutron and proton. So it gives you the idea how different it is between an alpha particle that's got a mass of 4, yeah, big particle, and then a beta particle which is 1/2000th. It's an electron, it is tiny. Yeah, and because it's an electron, it's got a charge of -1. So we've got alpha, beta and gamma. Now the key thing is with exam questions is being able to put those ideas about range, the range of the particles, the ionisation caused by the particles, and the penetration of each of those particles. Yeah, so you've got to know about that. So the range, highest is gamma in terms of range, then you've got beta, and the lowest is alpha. So when it comes to that exam question, they use quite a lot, which talks about how the danger changes as you move further away from a source or with distance from a source. You're going to be saying that close up, closer than 1 to 2 centimetres, alpha is the most dangerous. As you move further away from sort of 2 centimetres to 2 metres, beta is going to be the most dangerous, and then when you get over 2 metres, gamma is going to be the most dangerous because of their ranges in air. So you would link in that. So that's what you'd be talking about there. When it comes to ionisation, you'd be discussing that the most ionising is alpha, and therefore very close up, alpha is going to be, so closer than 1 to 2 centimetres, alpha is going to be the most dangerous, whereas the least dangerous is gamma, and in the middle is beta in terms of ionisation. But both of those are weakly ionising. But and this is where you've got to, you know, make your argument, is in terms of penetration, the most penetrating is gamma. The least penetrating is alpha. And in the middle we've got beta again. So even sort of 1 to 2 centimetres, if you're, you know, if it's outside your body, alpha is still going to be the least dangerous. So you'd be putting that in there. So, you know, this would be a 6-marker question. And you just go through and you'd say, you know, close up, the most dangerous, or inside your body, you'd be saying the most dangerous is alpha, because it is the most ionising of the 3 radiations. You'd then say, however, as you move further away from it, alpha will become less dangerous, and alpha only has a range of 1 to 2 centimetres. Above, and then you say between 1 to 2 centimetres and 2 metres, beta, although weakly ionising, has a larger range and therefore would be more dangerous than the alpha. Above 2 centimetres, you'd then talk 2 centimetres. Above 2 metres, you'd then talk about gamma being the most dangerous. And then you'd also say gamma is the most penetrating, and therefore, you know, it can't be easily shielded against. So these are the properties, and these are the properties you are expected to be able to recall about them. You might see on the internet and in some older revision guides about their deflection in magnetic field and things. You don't have to know that anymore. All you're expected to know is their range, their ionisation and their penetration, and then use that to come up with an argument about which is the most dangerous in the situation that they talk about in the exam question they give you. As long as you get the facts in there about them, which way you decide to argue doesn't really matter. They're looking for you to be able to state which has got the most range and what those ranges are, which is the most ionising, you know, what the dangers of ionisation are, damage to DNA, kill cells, damage cells, increase the risk of cancer. And then they're expecting you to be able to say which is the most penetrating, the least penetrating, and, you know, talk about what stops them. So paper, aluminium, not completely stopped by lead. And then you just then you make your argument up. But as I said, it's getting the facts, these facts in there that they're looking for. That's what's going to get you into the 5 to 6 mark. And then how well you argue your point would be whether you got 5 or 6 out of the 6 mark on the 6 mark question. Okay, hopefully this helps. I've got to figure out how to upload now 22 minutes, but we'll give it a go. Okay, bye.